Hello everyone, thank you for joining us today. We are excited to share insights on AWS IoT, a suite of managed services provided by Amazon Web Services that makes it easier to securely connect and manage IoT devices at scale. This seminar will provide a comprehensive overview of AWS IoT and explore its capabilities, challenges, and use cases. To start, let's set the stage by discussing the importance of IoT. Today, more than ever, businesses are incorporating IoT solutions into their operations, from cities in connected vehicles to industrial automation in healthcare. IoT applications are transforming industries. This transformation is driven by vast amount of data generated by connected devices, which can offer actionable insights when we proceed efficiently. Our seminar will cover four main areas: the fundamentals of IoT, the core services offered by AWS IoT, how AWS manages device security, and some real-world use cases. By the end of this session, we hope you have a clear understanding of how AWS IoT enables developers and its organization to create intelligent IoT applications. I'll now pass it over to Harini to explain what IoT is in greater detail.
Okay, now let's dive into the concept of IoT. At its core, IoT is about connecting physical devices, think sensors, appliances, vehicles to the internet, allowing them to collect and share the data. This concept has led to what we call a smart world, where objects around us can communicate and operate more intelligently. How does it work? IoT devices have built-in sensors that capture data. For example, a smart thermostat collects the temperature data, while a smart vehicle might gather information on speed and engine performance. These devices then use the internet connection to transmit the data to a central system or cloud, where it can be analyzed and used to make the decisions. IoT allows us to monitor, control, and automate processes that were previously manual or disconnected. One of the main benefits of the IoT is real-time decision making. Imagine a factory where machines can detect potential malfunctions and notify maintenance team before a breakdown occurs, or a smart home system that adjusts lighting and temperature based on the occupancy and weather conditions. The applications are vast, but so are the challenges, such as managing large data volumes and ensuring security. AWS IoT addresses these challenges by providing scalable, secure services for IoT devices. Next, Nivashni will explain AWS IoT core services.
So now let's look at AWS IoT Core, which is the main service for building IoT applications on AWS. AWS IoT Core is a managed service that lets devices interact with AWS cloud services easily and securely. With IoT Core, you can connect billions of devices and route trillions of messages to AWS endpoints and other devices without managing infrastructure. There are few key components of AWS IoT Core. First, we have the message broker, which enables secure, low latency, bidirectional communication between IoT devices and the cloud. This component supports MQTT, HTTPS, and WebSockets, allowing for various communication protocols based on the device capability. Then, there's the device shadow feature. This creates a virtual version of each device, storing its current state. For instance, if a light bulb is turned off remotely, the device shadow will update to reflect the status. This allows application to interact with devices even when they are offline, and any changes get applied when the device reconnects. Another vital feature is the rules engine, which lets us filter and route data based on predefined conditions. For example, if a sensor sends a temperature reading above a certain threshold, the rules engine can trigger an alert or invoke a Lambda function to take corrective action. These tools simplify IoT application development significantly. Now, let's move to the device management, which Raji will cover next.
Thank you. Now that we have discussed AWS IoT Core, let's explore the benefits of IoT. With thousands or even millions of devices connected, managing them efficiently becomes crucial. AWS IoT device management provides tools to register, organize, monitor, and update the connected devices. The first step is the registration, where each device is given a unique identity. This is essential for monitoring and securing each device individually. AWS IoT allows batch registration, making it easy to onboard large number of devices simultaneously. Once registered, devices can be grouped into categories based on attributes like location, model type, simplifying the management. Next, we have remote management features like AWS IoT device management includes built-in tools to monitor the device status and update the firmware remotely. This includes scalability, integration with AWS services, and enhanced security features. Overall, device management in AWS IoT simplifies the lifecycle of management of devices, helping companies to maintain efficient and secure operation. I'll now pass it over to Harini to discuss about the next topic.
Okay, now let's see about the data processing and analytics. Once devices are connected and managed, the next step is making sense of the data they generate. AWS IoT provides several tools for data processing and analytics. One of the core services here is AWS IoT Analytics, which helps collect, process, and store the data for the analysis. AWS IoT Analytics can filter and transform the raw data from the IoT devices, removing unnecessary information and structuring it for the analysis. This is essential when dealing with massive amount of data. IoT Analytics also integrates with Amazon QuickSight, allowing us to create visualizations and gain insight quickly. For real-time data processing, we can use AWS Lambda in conjunction with AWS IoT. Lambda is a serverless computing service that automatically scales as needed. For example, we can set up a Lambda function to monitor the temperature sensors and send alert if value exceeds safe thresholds. These analytics and processing capabilities make AWS IoT a powerful platform for deriving actionable insights from data. Now, Raji will Now Nivashni will discuss how AWS IoT encourages security, a critical factor in IoT deployment.
AWS IoT security. Security is a paramount in IoT. AWS IoT employs a multi-layered security approach to protect devices, data, and connections. It includes features for device authentication and data encryption, access control, ensuring security from the device level to the cloud. First, device authentication verifies that each device connecting to AWS IoT is authorized. AWS IoT Core supports both X509 certificates and AWS SIG v4 for this. Each device has its own certificate, allowing secure, encrypted communication between the device and the cloud. AWS IoT also uses data encryption in transit and at rest, preventing unauthorized access. Data transmitted between devices and AWS endpoints is encrypted with TLS, while data at rest can be protected with AWS Key Management Service. Finally, AWS IoT supports fine-grained access control, allowing administrators to define permissions for each device. For example, a temperature sensor might only be permitted to send data to the AWS IoT core, but not to read data. With these security features, AWS IoT ensures comprehensive protection for connected devices and data. Now, Raji will share some use cases of AWS IoT.
Thank you. Let's look at some real-world applications of AWS IoT. AWS IoT is used in diverse industries like healthcare, automotive, and smart cities. In manufacturing, AWS IoT enables predictive maintenance. Sensors on equipment can detect anomalies and trigger maintenance alerts, preventing costly downtime. In healthcare, AWS IoT allows for remote patient monitoring. Devices can track vital signals and send data to the healthcare provider in real time, ensuring timely intervention if any issues occur. For example, wearable devices can monitor heart rates, alerting doctors if irregular patterns are detected. Another interesting application is in agriculture. Farmers can use IoT sensors to maintain and monitor the soil moisture, helping optimize irrigation and reduce water usage. AWS IoT enables farmers to automate irrigation based on real-time data, improving crop yield and sustainability. These examples demonstrate the versatility and power of AWS IoT across industries. Now, Harni will come upon to speak the next topic.
Let's see about the challenges and considerations. While AWS IoT is a powerful platform, there are challenges and considerations. One challenge is handling vast amount of data generated by devices. Efficient data management strategies are needed to store, process, and analyze data without high cost. Another consideration is device compatibility. Not all the devices support the same communication protocol, so it's essential to plan for interoperability. AWS IoT Core supports multiple protocols, which helps but doesn't completely eliminate compatibility issues. Security is always a concern. Although AWS provides a robust security features, it's crucial to implement proper device security on the client side too. Devices need strong passwords, regular firmware updates, and secure network connections. In conclusion, while AWS IoT offers solutions to many IoT challenges, successful deployment requires a careful planning and ongoing management. Thank you.
Future trends in AWS IoT and IoT industry. Let's talk about the growing trend of edge computing and 5G in the IoT landscape. Traditionally, IoT devices have sent data to be centralized cloud servers for processing. However, as the number of IoT devices has increased, this approach has led to latency issues and increased network load. Edge computing addresses these challenges by processing data closer to where it's generated. AWS IoT Greengrass is an Amazon's answer to edge computing. It brings the power of AWS services to local devices, enabling them to act intelligently and process data in real time without relying on a constant internet connection. Building on the edge computing capabilities, let's now explore the integration of artificial intelligence and machine learning in IoT, which is another key trend shaping the industry. AI and ML are transforming IoT by making devices smarter and capable of self learning. Instead of just collecting data, IoT devices can now use the AWS services like SageMaker to analyze and act upon data in real time. For instance, an IoT enabled camera in retail store can use machine learning to analyze customer behavior and provide insights that improve the store layout or customer engagement strategy. One of the exciting applications of AI and ML in IoT is predictive maintenance. Next comes the sustainability in green IoT. IoT technology is being increasingly utilized to promote sustainability in various sectors from agriculture to urban infrastructure. For example, in agriculture, IoT sensors can monitor soil moisture levels and adjust irrigation systems accordingly, saving water and reducing resource wastage. As a wrap up, it's crucial to highlight the robust security features which remain a top priority as IoT continues to evolve. With rapid growth of IoT, security risks have increased as well. AWS IoT provides robust security measures such as device authentication, encryption, and continuous monitoring, which aligns with the latest industry standards and trends. Thank you all.